Today's learning target is I can find the surface area of a cone. Here you see a picture of a cone. On the bottom of the cone is a circle, and the radius is identified. And of course, this would be the height of the cone. This top point would be the vertex. And from the vertex down to the circumference of the circle of the cone is your slant height. So we're going to figure out the surface area of the cone. So the circle at the bottom plus this curved lateral surface around the circle. Our vocabulary includes cone, area, radius, circumference, height, and slant height. Those are two different heights there. So here we have a picture of a cone, and I've inverted it now. So here's our circle at the top, and our radius is from the center to the circumference. I've kind of separated the two so you can see the circle at the top, and here's that lateral surface being opened, and here's the net of the cone. We have the circle for the base, and then if we open up the curved lateral surface, it looks like a sector. So the radius is the r, and if we found the area of the circle, remember the area of the circle is pi r squared, and we're going to add it to the area of the sector. And the area of the sector is pi times r times L, where L is from the vertex all the way to the circumference, or the slant height of the cone. In other words, this all the way up is your slant height, or from here all the way up is your slant height. From the center of the circle all the way straight down would be your height, and from the vertex up to the circumference would be your slant height. So the surface area of the cone is the surface area of the base, or the circle, plus the surface area of the sector. So we have pi r squared plus pi times r times L. So if we look at the curved surface of the cone, this sector here, and we just snip a little bit of it, and we move it over here, and then we snip another little piece of it, and we alternate the pieces, you can see that we can use the area of the sector to make a rectangle. The width of the rectangle is going to be the slant height. So this is going to be the width of the rectangle. That's where they got the L, the slant height. And remember, circumference of a circle is 2 pi r. We have pi r up here and pi r up here, down here, because half of it will be across the bottom with the green triangles, and half of it will be across the top with the yellow triangles. So if we found the area of this rectangle, we would take the length, pi r, times L, the slant height. So the surface area of the cone is going to be pi r squared, the area of the circle, plus the sector, which is pi r L. So the key concept is the surface area formula. We just discussed it. This is the circle, pi r squared, and then I explained to you how we got the surface area of this lateral curved surface that forms a sector when it's opened up for the net. So here's like a snow cone, okay? And the cone would actually be right here, straight down to the vertex, and straight up again to the circumference. We're not measuring the ice itself, we're just measuring the cone part. So if 10 millimeters is the diameter, the radius must be 5 millimeters, and my slant height is 14 millimeters. So I plug in my formula. I've got 5 squared times pi for the area of the circle, and I have 5 times 14 times pi for my area of my sector. That gives me 25 pi plus 70 pi, which is 95 pi, and when I multiply that out with pi being 3.14, I get 298 3/10 millimeters squared. Remember, we're doing surface area, so we measure that in squares. Here we have another cone. Again, we have the same radius of the 5, but it's actually 5 centimeters this time. We're given the height of the cone, which is 12 centimeters. We don't need that for the formula, but we'll see that that is handy information later on. And the slant height from the circumference to the vertex is 13 centimeters. So if I lay out my formula and I plug in 5 for the radius and 13 for my slant height, I will find 25 pi plus 65 pi, or 90 pi, and when I multiply that out, I get 282 6/10 square centimeters. Now, in this next example, I'm missing the slant height, either that one or this one. If I know the slant height, I can use the formula. I know that the radius is going to be 2 yards because the diameter is 4 yards. So the radius will be 2 yards. And I know that the the height inside the cone, that is perpendicular to the base, is 5 yards. So now I need to use those two pieces of information to find the slant height of the cone so I can plug it into the formula. I need to know the slant height. So if you look at this right triangle, you'll see that we can use the Pythagorean theorem to figure this out. We know that the height is 5. We know that the radius is 2. So if we do 2 squared plus 5 squared, we'll get the slant height squared. So 4 plus 25 is 29. The square root of 29 is 5.4. So we can plug in 5.4 yards for our slant height. And then we can put in our radius and go through our formula to find out that the surface area is 46 and 47 square yards. There was an added step here because we didn't know the slant height. We had to use the Pythagorean theorem to figure out what the hypotenuse squared was and then find the square root of it. Before you finish, tell me something that you learned or were reminded of and a question that you have.